for Christmas. So, with this one here, we've already done the differential of the substitution, which we've got over here. So u differentiates to give du dx is 4x, rearrange dx is du over 4x, like that. And then we swap as much as we possibly can into the original integral. So, we end up with this. I'm going to put x equals 0 and x equals 2 there. We need to change those limits if we can. So x cubed square root of u, and instead of dx, we're going to write du over 4x. So it's not looking bad. Once we've done the substitution, the next thing to do is cancel. What cancels? X, and this becomes x squared. I'm going to remove that 4 out to the front just to get rid of it. So I end up with a quarter x squared square root of u du. So, it doesn't look great because I've still got that x squared there.
Can you write it down as u to the power of a half?
You could write u to the power of a half, and that's what we'll do a little bit later on, so that's good, we'll do that later. But I've still got this x squared getting in the way. So, I need to go back to my original substitution, which is u is equal to 2x squared plus 1, and then rearrange. So, what is x squared equal to from that?
U minus 1 over 2.
U minus 1 over 2. Now I swap that back into there. So I've got a quarter, and we've got u minus 1 over 2, and using u to the half as suggested in there, everything now in my integral is u's, which is great. I'm going to change my limits here and here as well. So if x is equal to 0, going back to my substitution, I swap 0 into this, so I get u is equal to 2 times by 0 squared plus 1, which gives u is 1. So u equals 1 is my bottom value, and x equals 2 gives me u is equal to 2 times by 2 squared plus 1, which gives u is equal to 9. So now everything has been changed from x's into u's, and now I can do the integration. Another little bit of simplification, I don't really like that 2 there, so I can bring it to the front as well, and that'll become, what do I get at the front now? An eighth. So get all those horrible fractions out of the way. Expanding this bracket, u times u to the half is u to the power of?
U times u to the half.
U's power equal to?
Not
3
U.
over 2, good. Minus 1 times u to the half is u to the half. And now I'm in C2, or in fact C1 territory, and I should be able to integrate both of those two things. So let's do that. Square brackets to show I have integrated.
5 u to the power of 5 over 2 over 5 over 2.
So it's over 5 over 2.
So 2 u over 5.
Yeah, so we can write that as 2u, yeah, like that. Minus
3 of u to the power of 3 over 2 over, so 2 over 3.
2 over 3, and that's between 9 and 1. And then at that point, we can just swap the numbers in, excuse me, and we get 1/8. So we've got 2 times by 9 to the power of 5 over 2 over 5 minus 2 times 9 to the power of 3 over 2 over 3 minus, and when I put 1 in, 2 times by 1 to the power of 5 over 2 over 5 times 2, 3, 1, 3 over 2. And if I evaluate that, then I have my exact value.
So does u equal 1 for both of them?
So u is equal to 1 and 9. So we put 9 in first and evaluate that. Then we take away whatever we get when we put 1 in. So we're going to end up with, might need a bit more space than that. So 1/8 of square root of 9 is 3. 3 to the power of 5 is 243. Times by 2 is 846 over 5. Minus 27, 9 minus 18. Minus, and then put 1 here, it's going to be 1 to the power of anything is 1. So end up with 2/5 minus 2/3. And then it's just a case of working out what all that is.
Well, so between the steps between, you know, when you have the quarter and the 8, is that because you take the 2 from underneath the u minus 1?
Yeah.
And then below that, you're just expanding the u minus 1 times
Yeah.
u to the power of half.
Exactly right.
going to write another step.
And yeah, whatever that is, you just need to work it out.